Hey everyone, Brandon Lee here with Virtualization How To. And if you're like me, you love home labs, and not just for tinkering, but for seriously leveling up your IT skills. And today we're diving into something that I am very passionate about in the home lab, and that is automation. And I think with AI and so many other tools out there now, the barrier to entry with automation and scripting has never been lower. Now, we're talking about using Terraform, Ansible, and CI/CD pipelines to take your home lab from just manually clicking around to a fully automated, working, well-oiled machine for reproducible deployments. And trust me, once you go down this road, there's no going back. You're going to be hooked with automation in the home lab. So let's jump into why you should automate, what tools to use, and how to get started, even if you're just running a few VMs at home. So first, why automate? What is the point of automation? And I get this question quite a bit. Many feel, and they ask this because they assume, isn't it just faster to spin up a virtual machine or install an app manually? Sure, it may be easier doing that just once, but what about every time you want to test something? Or what if you need to rebuild after a failure? What about applying updates to dozens of virtual machines? Here's the value you get from automating. First, you get consistency. What I mean by that is everything gets provisioned the same way every time. And if you're like me, if you manually click things, even doing that many times over, you're bound to do something a little bit different at least once. Also, efficiency. You eliminate repetitive tasks. Scalability. Growing your lab becomes effortless. Version control. When you commit your code to Git, you can track your changes over time. Disaster recovery benefits. When you're rebuilding your lab, this becomes just a few clicks of a button. It's basically turning your lab into a mini enterprise environment. There are a lot of automation tools out there, but three tools in particular have stood out in my home lab environment, and these three tools are going to be the focus of the remainder of the video. First, we have Terraform for provisioning, Ansible for configuration management, and then finally, CI/CD pipelines for automating your workflows with these other tools. First, we have Terraform. Terraform is an infrastructure as code tool, or you may have seen the acronym IAC. First up, we have Terraform. Terraform is an infrastructure as code tool, and it allows you to describe your infrastructure in code and then deploy it consistently, either on premises or in a cloud environment. You basically write what you want in a .tf file or Terraform file, for example, a Proxmox VM or an AWS instance. Terraform then takes that code and makes the infrastructure a reality based on what's described in the Terraform code. It uses what Terraform calls providers, and these are basically like plugins if you want to think of it that way. It allows Terraform to connect to environments like Proxmox, VMware vSphere, AWS, GCP, Azure, and many other environments. Let's take a quick example of running Terraform for Proxmox and see how this works. And I think as you get your eyes on the code, how it works, and what we're actually doing here, you're going to quickly see the benefits of this process. Okay, I'm going to show you just how easy it is to use Terraform along with your Proxmox environment for automation. So I have three files that I've created, and I have a blog post that I'm going to link to in the description for this video that shows you the source code for all of the files that you need to create. So I've got a main.tf, I've got a variables.tf, and I have a terraform.tf vars file. Now the main.tf file is the file, if you think of it this way, that does the work. It's actually where the automation happens, and it carries out the activities and tasks that you want for your automated process. Now the variables file is where we define our variables, and the terraform.tf vars file is where we have sensitive information. So if you choose to, this makes it easy splitting it out this way if you choose not to commit this file to source. So like if you've got a Git repository where you're housing everything, you could choose not to commit your TFVARS file, which has the sensitive information. Alternatively, you could have a secure variables location like HashiCorp Vault. If you're using CI/CD, which I'm going to get into in just a couple of minutes, you can store these as secure variables. That gives you an overview of the files that we actually need to carry out our automation. Now with Terraform, there are 3 commands that basically do everything. There is a Terraform init command that we want to run to begin with. What this command does is it looks to see any plugins that are required to run this code. And as you can see, we are referencing the Telmate Proxmox plugin. So when we run this Terraform init file, it's going to say, okay, we need the Telmate Proxmox plugin to run the automation. So I'm going to just simply run the Terraform init command. And as we can see, it's finding the latest version. It's installing Telmate Proxmox, and it tells us that it's now been successfully initialized. So if you see green here, green text in your output, as well as this successfully initialized, you know everything is good to go. So I'm just going to clear real quick. The next command that we can run is a Terraform plan. What Terraform plan does is it basically checks your syntax, it checks all of the files that you have in place, and it gives you an output of what is going to actually happen when we run this Terraform code and perform our automation. So as you can see, the code has the green pluses next to all of these resources. What that tells you it's going to do is actually run a creation for these resources, allowing us to create them. So if you go through here and you see all of the resources that we are creating, we can tell that Proxmox thinks, hey, I'm going to add all of these things to your environment. Now, what I'm doing with this code is I have an LXC container image I've downloaded, which is the Ubuntu 2404 standard image that is available if you just go to download images for the LXC containers in Proxmox. You're going to find that this one is available. So all I've done is I've pre-downloaded this into my inventory as an image. And what this code actually does is it goes through and it creates whatever number that I place in this variable, the LXC count. So I could spin up 20, 200, 2000, whatever the case is. And just for this example, I'm just going to spin up 10 containers based off of that image. And so I want to save this file just so I know I've got the latest version. Also, and this is contained in the blog post that I reference, you will find information on how to create your API token ID and secret. You will need this for Terraform to interact with your Proxmox environment, as it does this using the Proxmox API. And then, of course, we've got an LXC password that we're setting here and our Proxmox node, and of course the URL for the API interface, expected things, but just note that you will need to create this API token and secret prior to working with Proxmox using Terraform. All right, so now the fun part begins. Let's actually run, now that we've seen the Terraform plan, let's run a Terraform apply. So if you notice, this is identical to what we saw with the Terraform plan. And note here, this lines up with our code plan 10 to add. So in other words, 10 LXC containers that we're going to add. No changes are being made except the additions, and this is key as well, nothing to destroy. And that's a good sanity check. If you're running code, you expect, hey, I'm only creating resources. If you get here and see that things are getting destroyed, you know, hey, I may need to go back and look at my Terraform code, at my state data that Terraform is actually keeping up with. All we need to do at this point is simply type yes, because Terraform is asking us, okay, here's what I expect I'm going to do in the environment, 10 to add. So it's asking us type yes to accept and to approve. So I'm going to just press the enter key at this point. And I want to quickly show you what's happening inside of Proxmox. We can now see the LXC containers being provisioned as we speak, and it's going to spin up 10 LXC containers. And look at that. Look how quickly we are getting these LXC containers provisioned in the environment. instead of me pointing and clicking through the wizard. And here's what's really cool. As you can see, the LXC container is already named. If I click through these, you can see 4, 5, 6, 7, so on and so forth. And I can actually log in with the let me in $1. If I can type password, and boom, there we go. I hope by now you're beginning to see the value of automation, especially with Terraform provisioning resources. Well, hopefully that example shows just how quick and easy Terraform is to provision your virtual machines in something like Proxmox, VMware vSphere, or even cloud environments. Now, while Terraform can do some configuration management tasks, another tool really stands out for that purpose, and that's Ansible. Ansible really owns that part of your automation. So think of Terraform as your infrastructure builder, and then Ansible takes that infrastructure and it then configures it based on your Ansible code. Ansible is your go-to for configuration management. Whether it's installing Docker, updating packages, or tweaking settings across a number of VMs, Ansible is able to do this very fast and in a repeatable way. I use it all over my lab. For example, I have a Gitlab CI CD job that grabs all of my Linux VMs from my virtualized environment, and then it runs updates on those Linux VMs using an Ansible playbook. And I want to go back and retrofit actually running Ansible for Windows updates, as I've had another tool that I've been using for that, but this is another home lab project that I look to tackle in 2025, and stay tuned for a video on that as well. Let's look at a cool playbook for installing updates using Ansible in something like Ubuntu Server. So here I'm logged into WSL and Windows. I'm listing out the directory, and you can see I've got 3 files: all updates, inventory, and security updates YAML files. Let's look at a tree view. We can see the same 3 files there. And now let's take a quick look at the inventory file. In this inventory file, we define a group, which I have defined as Linux, and I have a single machine in there. Listing out the directory again, you see we've got the all updates and security updates YAML files. Let's take a look at all updates.yaml. And this is the Ansible playbook code in YAML that we can use to apply all of the available updates in Ubuntu Server, or a Linux server in general. We can see we're updating a cache, we're upgrading, and now let's take a look at the security updates YAML file. Very similar, except what we have done is we are filtering for security updates. So this is cool. You can actually apply only certain types of updates. Now let's take a look at the Ansible ping command. And this ping command makes sure that we have established connectivity to our target server or servers. So you can run this against your inventory file and actually see if that's successful. Now let's take a look at the playbook. Let's run the Ansible playbook command, and we're going to pass in the all updates YAML playbook. We're going to pass in our inventory file. And as you can see, the playbook kicks off, and I'm going to speed up the video here as it completes. And we can see that we successfully changed CL Docker test. We've got 2 okay, changed 1. So everything was successful. Now, I think the real benefit and icing on the cake with Ansible is that no agents are required. Let me repeat that. No agents are required. All you need is just a simple SSH connection or something like WinRM with Windows, and you're good to go. Of course, you can also use SSH with Windows as well. Now, here is where things really click into place with CI/CD pipelines. It's like the glue that holds everything together and brings it all together to work cohesively. Instead of running Terraform and Ansible manually, you can create a CI/CD pipeline that does this automatically whenever you push a change to your Git repo. Especially if you're testing things or making updates, this makes it super easy, as you know that each code change that you push to the Git repo is then pushing that change out to your infrastructure by means of that CI/CD pipeline. Now, as for a CI/CD pipeline, what tools do I recommend or do I use? Well, you can use something like GitLab CI, GitHub Actions, Jenkins, or even Drone CI. I've used all of them in the home lab, and I've settled around Gitlab CI as it is what I have found to be the most robust tool for my use case. However, all of those other tools that I've mentioned are extremely powerful. At a certain point, it comes down to personal preference. However, I do like the fact that GitLab also has the pipeline functionality built in natively. There are no bolt-ons required as there are with some other solutions like Drone CI. Let's see how to do that with a real-world example. So now let's move into thinking about using a CI/CD pipeline for running our automation in the home lab. So what I have is a repository that I've called vSphere Linux Inventory and Update, and this could very well be Proxmox as well. But our script is going to be tailored to which virtualized environment and technology that we're working with. In this case, it's vSphere. And I have what is known in GitLab as a GitLab pipeline file. And they all look like this, the .gitlab-ci.yaml file. And inside of that, we have the stages and steps that are used to run the pipeline. And I'm going to get into that in just a second, but I want to first highlight the two other resources that this pipeline makes use of. The first of which is called Generate Inventory. Now, this script in particular goes out and it connects to my VMware vSphere environment using secure environment variables that are housed inside of GitLab. So we don't have to worry about exposing anything in our actual code that we have in this resource, but it connects to our VMware vSphere environment and it looks for all powered on virtual machines that have the guest OS full name matching Linux. And I have an exception in here for a particular Linux box that I want to be hands-on with, and I don't want to be included inside of this list, just so you know what that is in that PowerCLI command. For each of those, we are getting an inventory count and just the VM name, and then we're outfiling that into an inventory.yaml file. Now that inventory.yaml should be familiar from our previous walkthrough with Ansible. This is our Ansible inventory file. So that script goes out to vSphere, pulls all the VMs matching Linux, creates that inventory.yaml file, and then we also have an Ansible resource here called updatelinux.yaml. Now this should also look very similar to the other resource that we looked at, our Ansible Playbook file. This one has a bit more logic. We're also pruning our Docker container environment with this. However, this section should be very familiar. We are upgrading all packages to the latest version. So you can see very familiar syntax here. We've got a few other script logic statements in here. We register if a reboot is required, and then also we report back if there's a restart that is recommended. So that is the Ansible playbook. Now, if I go back to the root of the repository, let's now look at the GitLab CI YAML file. So if I open this up, we can see we've got a couple of stages, and these go with those scripts. So the generate inventory stage is where we actually call that PowerCLI file generate_inventory.ps1. That's going to grab all of our Linux boxes. It's going to create the inventory.yaml file, and then we have our second stage that is run Ansible. Now, our run Ansible stage is going to spin up a Docker container, install Ansible. It's going to do some magic here with a private key so it can connect to all of our Linux servers that are included in that inventory.yaml file. And then our script is the Ansible playbook that we looked at, updatelinux.yaml. But as you can see, the pipeline is very intuitive with the stages that we have here. We call those files, and we're able to run this pipeline as often as we want in our environment and actually pull the Linux servers that need updating and then running this Ansible update script via this pipeline. So hopefully this shows just how powerful CI/CD pipelines can be when you combine the pipeline itself with other technologies like Terraform and Ansible. You can do some really amazing automation, not only inside a home lab, but also in production environments. Now let me share some tips that I have found and picked up along the way that I feel are best practices to allow you to be the most successful when applying automation in a real-world way in your home lab. First of all, start with a real project. Don't automate just to automate. Solve a real problem. That's when I found things really started to click, when I had a real world use case. For instance, updating all of my Linux servers. Use Git for all of your configs. Track everything. Secure your secrets. Tools like HashiCorp Vault, Ansible Vault, or Your CI/CD environment with secure variables are your friends here to keep from exposing sensitive data. And when you learn how to treat it this way, it's going to help you as well in production environments. Test locally first. This saves you a lot of pipeline frustration as you work out the kinks locally and then merge to your Git repo. Monitor and log everything. You can use Grafana, Prometheus, InfluxDB. All of those things are great tools. Back up your Terraform state and your Ansible playbooks. That's your infrastructure snapshot. So to wrap things up, automation in the home lab isn't just about convenience or just something to look cool. It's about learning real DevOps skills that can scale not only in your home lab, but also in production environments. Once I started combining these tools, Terraform, Ansible, and CI/CD pipelines, that opened up a whole new level of control and confidence in what I was building. Well, let me know in the comments what you're automating in your home lab, or if you've got a unique workflow that you've built out and would love to share. And if you want to see deeper dives into Terraform configs, Ansible playbooks, or CI/CD setups, hit that like button and subscribe, as well as visit the VHT forums. I contribute there as well as other members of the community, helping ones out with various challenges they face in their home labs, including automation. Well, please stay safe out there, keep on home labbing, and I will see you in the next video.